talk about symmetry, okay? And when you think of symmetry, I'm guessing, automatically think of just what we're going to call line symmetry. But there's more than just line symmetry, okay? So our definition of symmetry, we have a shape, and there exists a rigid motion that maps the figure onto itself. Okay? Well, if we're talking about rigid motions, we have 3 of them. And a translation is probably not going to help us take a figure and map it onto itself. That doesn't make sense. So we have 2 kinds of symmetries. We can use a reflection, which is what you saw in 1 of 2 on your discovery. We're going to talk about line symmetry. Okay? And then the second part of your discovery was using a rotation. And that's what we're going to call rotational symmetry. Okay? What kind of symmetry as a human, most of our faces, well, if a face has what kind of symmetry, we like to say it's aesthetically pleasing. What kind of symmetry? Rotational? Probably not. Line symmetry, right? Our faces have line symmetry, okay? In a perfect world, but we are imperfect people, okay? So line symmetry we can reflect the figure onto itself. So like this half matches this half. Okay? So I'm going to draw a really cool picture. That is not as cool as I wanted it to be. I'll try again.
Like an arrow. Uh-oh.
Okay. I can rotate this figure about that teal line and it'll look the same. I can fold it in half and it'll look the same. Okay? Okay, now our line of symmetry is where our figure can be reflected to have our line symmetry. So we're talking about that guy right there. Okay, so our first job is going to be to look at a figure and determine, does it have line symmetry, and how many line symmetries does it have? Hello. You got something for me?
That was work done yesterday.
I love that for us.
What is it?
It's an assignment. Somebody was missing. Okay. Does A have line symmetry? Okay. How many do you think it's going to have? 1 or 5? Okay. Here's 1. Hey, we're going to have to draw them. 2, 3, 4. Okay. 5 of them. Look how beautiful that is. I'm hearing some conversations already. Does B have line symmetry? What did you say, Josh? You would go and try? Okay. It would take you forever because it doesn't exist. I appreciate the effort, though. That was a appropriate time for that. Thank you. What about C?
Yes. 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 What two? There's two. Go for the angles.
Okay.
Go for the angles.
If I fold it along this line, it'll look like that. If I fold it along this line, no, it'll look like this. Okay, what else? If we do this, no, it will look like that.
You just gotta do some origami here. You can get it.
There is no line symmetry. I'm sorry that you feel that way. You know what it does have? It does have rotational symmetry, and we'll talk about that here in a moment. Okay.
Yes, sir.
Do you want me to get a parallelogram for you? Like, do you need a paper parallelogram to? You do? How about you fold your paper?
I hate that it's not full. They're just not parallelograms. Or wait, they are, but like they're not. Doesn't make them the same.
Okay, Billy, how do you do this?
13. I need.
Trace it. Trace it. Who else doesn't believe me?
Me. I believe you.
Kale.
I believe you before Kale believed you. Yeah.
Okay. Trace it.
I just want
Together. Trace it.
Kale needs confirmation. Kale is not ready to get proven wrong.
I got proven wrong, guys. I'm gonna do what Jay did.
Okay, I have some people who are gonna trace it. So now, okay, you traced it? Just a minute.
Kale doesn't like being proven wrong.
So if we trace it, and then we're gonna fold it along this line that you think is. Try to see if you can pull it away. Okay. Okay, does D have line symmetry? How many do you think? Okay, here's one. Here's two. Here's three.
Point to point.
Okay, then vertex to vertex. 4.
6 or 7.
5. That was bad. 5. Here's 6. Where else can I draw?
Yes.
There's only 6.
Oh, each one is a pair?
Yes.
Well, it's an entire line.
So then what's this?
There's 5 lines there.
I counted the lines.
No, you counted surrounded by
One.
You counted 12 total ones that talk. Don't 2 of them go together.
All right. So let's. Okay. Rotational symmetry. Means if a figure can be rotated onto itself with a rotation less than 360. Okay, so we looked at an equilateral triangle in our discovery warm-up, blah, blah, blah. Okay, now point symmetry means we have rotational symmetry of 180 degrees. So that parallelogram that you guys were stuck on, it does not have line symmetry, but we could say it has point symmetry because it has rotational symmetry of 1.
Oh, wait, that's also true.
I am full of truths.
Shapes are weird. See, this is why I should be in this I am. I have to write the essay thing.
Okay, point of symmetry is going to be the point of rotation. So if you think about our equilateral triangle from our discovery, our point of symmetry is right there in the middle where we just kept turning it. That's where we would hold our pencil and then turn the vertices. Okay. Any thoughts on the magnitude? Okay. Our angle of rotation. So, what would the magnitude be of our equilateral triangle? No? 120 degrees. How do you suppose we could get that? Yes, but also math. How many times can we turn the equilateral triangle? 3 times. How do you suppose we use that 3 to get the 120? 360 divided by the 3 different turns that we can make. Okay? So let's go to the last page of notes. Okay. Does A have rotational symmetry? Yes. Here would be our point of symmetry right there. Okay. The order just means how many times could we rotate it? 5. Because it is a regular pentagon. We can turn it 5 times. Now, the magnitude, that's what is our angle. So how are we going to find that with this one?
Wait, is the rotational symmetry 180? Would it? If this was flipped upside down, wouldn't it not be symmetrical?
It still could be. We could still rotate it. Okay. How do we get this number?
360 divided by 5.
Yes.
90.
No.
I was pretty close with that.
What would have a rotational symmetry of 90? A square.
Oh, wait, yeah, that's right.
Okay. Okay, so I would like you and your elbow partner to discuss B, C, and D, and in 3 minutes we'll come together as a class.
So it would be no, yes, yes, and then
For this, you don't have to put.
I don't think there's anything symmetrical about this one.
so I think if we turn it 180,
Yeah, I don't think this one like functions.
so 2. Wait, yeah, 2.
What does order mean? I forgot. Oh, how many times?
Magnitude,
Oh, you can't. This is no. And then
Wait.
magnitude.
180.
What?
360 divided
There is no order for that.
I forgot what order it does.
Order is like how many times you can cut it and then flip it. But you can't flip this.
right?
Wait a minute.
Hold on.
Oh wait, no, you can't. Magnitude. I don't think there's any magnitude, but there might be. I don't know.
Are you supposed to have the degree symbol?
Yeah. Order.
Are you supposed to have the degree symbol for the
Yes.
magnitude?
Oh, no, this one's 6. I know this. The magnitude.
If the answer is yes, you can.
Oh.
How many times you rotate it to get it back to normal?
Oh. It's not great, but it's nice.
Oh,
I think it's better than order, so 180.
All right, Logan, does B have rotational symmetry?
No.
Oh, that is sad, but also saves us some time. Is everybody okay with why B does not have rotational symmetry? Does B have line symmetry? No. Okay. Excellent. Dot, does C have rotational symmetry? Samuel, of what order? It would be 2 because we can flip it upside down and then again to get it back to normal. So this number is how many times can we rotate it before it's oriented back to the original? Okay, which means its magnitude is 180. Okay, Ethan, does D have rotational symmetry? Aaron, of what order? 6, which means the magnitude would be what, Ellery? 60. Any disagreements there? No.